crinoids, but crinoids that have no arms, but so-called brachioles for feeding, elevated on a long stem, and having a constructional problem of having to introduce new brachioles for the food requirements of the larger organism. But they can be introduced only on the wrong side of the ambulacrum. And this problem was finally solved by, for instance, this form, in which growth at the tips of these, well, almost arms, coincided with the growth, the introduction of new feeding organs. Perfectly, finally in the Permian, they solved the problem that the group had from its beginning in the, when are the first blastoids? In the Silurian, I think. Yeah. And in the Permian, finally they reached the solution, but they died out. So it's not maladaptation. Or you go before the late Devonian extinction, Brand-Farmenian extinction, mass extinction, and before you have these trilobites that came to light, particularly after the fossil collectors in Morocco discovered this thing and made it a trade. And no matter how many of the specimens you are offered or buy are forged, but there is something real behind, and this is these horned trilobites. Now, why horned? Because the horns would be defensive. Now, for being defensive, the spine of a porcupine has to be straight. A sea urchin spine has to be straight to be offensive, to be of protective value. If it's an early warning system, it has to be straight to be far enough away. And they coil, apart from the fact that in a skeleton that does not grow like the horn of an antelope or a cow. It is fabricationally a problem because these skeletons are molted, and still they grow in a spiral that is useless for the usual function of these extensions of the skeleton. Well, of course they were good for something, but something else, sexual selection. Some ladies thought this guy is more handsome than the other one, which requires that their eyes were able to appreciate this difference. So you see, it reaches far, and nevertheless, that's the last bloom of this, of various groups of trilobites that participated in this context. And finally, I have to come to the Ediacaran. The Ediacaran is the last phase of the Proterozoic, as we've heard, and it's followed by what we call the Cambrian explosion. And most paleontologists think that the Ediacaran fauna, if it was a fauna, must have been the fuse, long fuse for the Cambrian explosion. In studying their construction, I came to the conclusion, no, they behave like unicellulars, because when you interpret these things as worms or sea pens or pre-trilobites, you turn them around, or jellyfish, or what, you have to place them in different phyla, not in unicellulars. If you look at coproliths or other unicellular organisms, particular flagellates, chrysomonadines, they go from one species to the other. They show complete change of growth plan because they do not have this complicated process of delegating and destruction to a cell, and this cell is delegated, and all this, it all happens in one cell. So, taking these as an extinct, completely extinct group that dominated the ecology before, and some of these become a meter long, but always quilted for protoplasm to be compartmentalized, and this goes on. But taking these as an extinct group called Vendobionts, we have a big mass extinction after this incredible golden age, in the shadow of which the first animals, multicellular, were around. There was a few, but the dominating part, the world before, was dominated by these unicellular dinosaurs. So much about golden ages. Now, golden biotopes, and here is the deep sea. In Darwin's time, one believed that the deep sea, there can be no animal life. It must be a tremendous desert because one knew temperatures are very low. There is no light whatsoever, no sunlight. So there is no primary production, there is no food, and it's very cold and tremendous pressures. Under such unfavorable conditions, the modern deep sea research showed just the opposite. It's more exotic, more diverse down there. True, the standing biomass is very low. You never see a swarm of fish, except in local oases called black smokers, where primary production takes place on a chemosymbiotic basis. But otherwise, the deep sea floor is nothing, and you go over it with the Alvin, and when you see a little starfish, stop, I have to take a picture. That means very low density, very low standing biomass, but nevertheless, almost every trawl or probe brings up new species. A tremendous diversity, and, what I want to show you, a tremendous disparity, exotic forms. Now here is, this is the unusual phenomena, but the explanation was given by Howard Sanders. There may be very unfavorable conditions, but there is the one favor of uninterrupted time. No days, no seasons, no storms. Even sea level rise and fall 100 meters, a few thousand meters down, that is not felt. So it's the time constancy that, in spite of the unfavorable conditions, makes it a golden biotope for evolution. Now, the next, here are just examples. So here is a fish, and you will say they look very much unlike the fish we expect on the fish market. Here, one that has these two appendages. This is